Today we are modeling a blackjack game, which is not a lot of code, but it comes with a backstory that describes how the program should work. So there are actually two documents that are being distributed today. The first document is directly lifted from topcoder.com. It was given as a programming assignment during one of their contests. We do have the right to use it because we are an educational institution. We're not violating any rules here as far as I know. And their problem descriptions provide a story in text describing how the program should work in general. And then it also provides a definition of the interface that should be written, the name of the class that should be written, the name of the method that should be written, and also the entire signature of that method. And then in the following page they provide examples to test the program, and usually they give 3 or 4 examples. If your program passes all of those test cases, you may want to submit it for consideration in the competition, where it is submitted to even more test cases. So these are excellent exercises for us to use in an academic environment as well. Just also to clarify, the Topcoder programs also provide constraints, and in my experience a lot of programmers confuse the constraints with something they have to program. That means these constraints will already be enforced in the examples that you get and the test cases that you get. In other words, you don't have to program this. You can assume this to be true when you're processing their data. And if you scroll down and look at the examples, you would notice that all their examples conform. All their examples conform to their constraints. So the only thing you should worry about in the constraints is upper and lower limits of your code, not worry about programming the constraints. Just otherwise they will always be there. The pseudocode is relatively short, and if you've written any code before, if you've heard me talk about code, you may have heard me say that a popular coding convention, almost a rule, is that a method should only exit out the bottom. There should not be multiple exits from a method. Well, I broke that rule here. As you can see, there's a multitude of ifs, and in each if there is a return. In other words, if the dealer does not have blackjack and the player does have blackjack, then we return 1.5 times the player's bet. Remember, every rule is going to have some special situations where it might be okay to break that rule. Every programming convention can probably be avoided in some circumstances. In this particular case, it's relatively elegant, and the case could be made that it's probably good code to have multiple return statements in this method. I'm not saying that it's perfect. I'm not saying that it follows all the rules that I always teach in my classes, but it doesn't look too bad. We will pursue our program development using this pseudocode, and then if we have time, we will look at rewriting this such that it exits out the bottom, and you can see the difference in the code. You can see the difference between the way the two versions look, and you can get a feel for which one you think might be easier to maintain in the long run. Because what we're concerned about when we say a method should not have multiple return statements, we're concerned about maintenance. We're concerned about someone else visiting this code at a later date and missing the fact that this method might return after the first line and adding some code that never gets executed. Our long-term goal then is maintainability. Now in this pseudocode that I wrote, I took some liberties. I used some Java keywords. I wrote the first line of the method almost completely in Java. So it's not totally generic pseudocode, but it should be readable for most programmers. I intentionally went with single equal signs for test for equality, and I left out a lot of parentheses. Certainly I left out the semicolons and curly braces and other delimiters. So it's relatively generic, if there is such a thing as relatively generic, and we can work from it. First thing we'll do is create a new project. The pseudocode and the problem description do not specify a project. That's a Eclipse specific entity. It is not a Java specific entity. Therefore I left it out of the pseudocode. So I'll call my project Blackjack game. We always put our code in a package. We never use the default package. Again, the pseudocode does not include a package, and the top code or problem description does not include a package. Therefore, we will make up our own package name. We will call this Blackjack package. And we'll create a class inside the package. The class name, according to the pseudocode, is Blackjack Winner. And that's taken directly from the top code or problem description. Blackjack Winner. I'm going to click the checkbox to create a main because there is no main called for in the pseudocode. The reason for that is that the top code or problems never include a main. If you compete in a top code or a competition, they give you them, they provide the main. You never see it. But we have to write one in this environment because we're not coding inside the top code or competition arena. Okay, we end up with a blank main, which is good. I'll just delete that comment there. Referring back to the pseudocode again, I have a method. Since I wrote the pseudocode in somewhat Java-friendly style, I'm going to copy the entire method signature out of the pseudocode, just less typing. I'll put that above the main for now, just to make it available. And that gives me a running start at my method, copied directly from the pseudocode, so it must be correct. I immediately get a squiggle, and the squiggle is an error because the method is committed to return an integer based on the method signature, but as is, it does not return anything. I can solve that problem in the short term if I want to by just putting in a return statement. It's not logically correct, but it makes the error go away. If you don't like that, you can just live with the error. Either way is fine. The error will eventually disappear when we write the code. So if it's annoying to you, you can add a return statement to suppress the error. If it doesn't bother you, you can just live with it. Either way is fine. We're still in the very early stages of development. Now this particular pseudocode is a maze of ifs based on the story presented in the top coder problem description. There's all kinds of different conditions that could be met. If those conditions are met, the player either loses, wins, or experiences what's called a push, which is a draw. So the player may lose money. In that case, the method returns a negative number. The player may win money. In that case, the method returns a positive number. Or the player may break even, neither lose nor win. In that case, the method returns 0. The first line of pseudocode says, if dealer blackjack equals 0 and blackjack equal 1, return bet times 1.5. In this case, the dealer did not have blackjack, but the player did have blackjack. The player wins 1.5 times per bet. The beautiful part about the pseudocode, and this should always be your goal, is that you don't have to know how to play blackjack. It doesn't matter. If the pseudocode is written properly, any competent programmer should be able to implement this pseudocode without knowing anything about the algorithm. So if there's an error in the pseudocode, the error should be transferred directly into the program. If you've never played blackjack, don't sweat it. Just translate the pseudocode and check your results. If your results are correct, that doesn't mean you're a blackjack expert, but it means you're a good programmer. I'm going to take this line of code, including the comment, copy it, paste it right into my method. As expected, I get all kinds of errors because there's no delimiters. The syntax related to Java is a disaster. That shouldn't be a problem for us. We know that whenever we create an if construct, we need parentheses. So I put parentheses around the entire logical expression. That's my first fix. My second fix is the word and. We don't use the word and to represent a logical test. In Java, we use 2 ampersands. That solves that problem. I'm still not done. We don't use an equal sign as a test for equality in Java. We use 2 equal signs. 2 equal signs there. 2 equal signs there. I'm getting home now. I'm doing well. I need a semicolon at the end of the return statement. The only problem I'm left with now is type mismatch. Cannot convert from double to int. Some languages like C and C++ will implicitly, without your intervention, convert a double to an int. They will truncate a floating point number to convert it to an integer. Java in this situation will not do that. Instead, Java wants you to know that there's a potential problem, and the problem is serious enough that it will not run. if you try to run this now, you will get an error. It's not a warning, it's an error. We need to fix this. We need to somehow cause this integer, rather this double, sorry, to be converted to an integer. Now how do we know this is a double? Well, let's look at it. We have bet times 1.5. Well, it's impossible for a computer language to multiply an integer times a float. It can't be done. Bet is an integer. We see it declared right there. It's one of the parameters to the method. 1.5, by definition, is a double. Whenever you use a numeric literal with a decimal place, it is a double. Java has a problem then. It cannot multiply an integer times a double. You can't do it. Instead then, it does an on-the-fly conversion of bet. It converts bet to a double. And we end up with double times double, which is good. And the result of a double times a double is a double. No floating point precision errors. Everything's good. The problem then arises when we look at the method, and the method is supposed to return an integer. So we've got a double here, but we're supposed to return an integer, and that's why we get the error message. Cannot convert double to int. It offers a couple of solutions. Change method return type to double. Sure, that would solve the problem, but that would violate the interface that we've already been given. This line of code right here cannot be changed. That was given to us by the designers, and it has to stay that way. Therefore, the second solution offered is not one that is reasonable to us. The second one, add cast to int. Okay. Eclipse is offering to put in a typecast to convert that double to an integer. That would solve our problem. Let's see what it does. Good. It took the result of a double times a double, which is a double, and converted it to an integer, and that matches this data type over here, and that should solve our problem, right? Well, now we got another problem pop over here. What is this? The method must return a result of type int. Well, it looks like that's what we're doing. It looks like double times double is double, and then that's converted to an int. But Java, or Eclipse, still is not happy for some reason. So what I'm going to do is put parentheses around that whole thing, and it's still not happy. So what if I put parentheses, or put a typecast there? How about that? Still not happy. The problem is that this return statement only applies if this if statement is true. If this if statement is false, it's going to drop down and continue through the code, and I did not provide a return statement at the bottom, so uncomment that, and everything is fine now. Looking back at the pseudocode again, I'm going to copy these lines one at a time, paste them into my program, and make the necessary edits. I think it's overwhelming to copy them all at once. You certainly could do it. I just like to be able to focus on one at a time. The second line of code, if dealer, blackjack equal 1 and blackjack equal 1, return 0. And semantically that means that if both players had blackjack, both players had 21, then it's a push and the winner or the player's bet is returned to him and he doesn't win anything. I need to make the same edits before. I need to put in parentheses. I need to put in 2 equal signs. I need to replace the and. Whoops. There's the second line of pseudocode inside the method. If you're careful and you replace the correct symbols with the correct Java equivalents, you should end up with a correct line of code. You can see now this method has 3 return statements. If this is true, it executes the first return statement. Otherwise, it continues on. If this is true, it executes the second return statement. So only one return statement will be executed each time you call the method, but it may look confusing at first. Another thing that you're going to see people do is put in more parentheses. Now I have no problem with this at all. This is written perfectly correct. Inside these parentheses there are 3 operators. Okay, Java has to decide which of the 3 operators to do first, second, and third. There's an equal right there. There's a logical and right there, and there's another equal or test for equality right there. Java has to decide which one comes first, which one comes second, which one comes third. It's deterministic. It's never going to run a different way. It'll always work the same. Everything's great. But you as a human being might be a little uncomfortable. Is it going to do this operator first? Is it going to do this operator first? Is it going to do this operator first? You're not sure. It's not a problem to put in more parentheses. In other words, force it to do that equal, force it to do that equal, and then finally the only thing left to do will be the logical and. So some nested parentheses is certainly acceptable, and it's a very common practice. If you're not sure of the order of operations, put the parentheses in, make it run the way you want it to run. I'll do the same thing here. Back to the pseudocode, grab the third line, copy, remember also that the parentheses around the return expression are also optional. This is a holdover from the original C language where they made that decision a long time ago to use parens or optionally not use parens, and Java carried that convention over into the implementation of that language. So parens there, either way, doesn't matter. Next line of code, Next line of code. This one's actually getting a little more logically complicated. And I'm piling on more parentheses. This one says, if the dealer is less than or equal to 21, at the same time the player is greater than 21, or the player is less than the dealer. So it's detailing two scenarios in which the player could lose. I've ended up actually getting parentheses nested 3 layers deep there. Again, not a problem. Parentheses are free. If they make your code easier to read, if they make the code easier for you to understand, put them in. Don't worry about it. I have a couple more lines of pseudocode. One more line. This is all the pseudocode that was provided for us now. I implemented it all in Java. I don't see any squiggles, which tells me that the syntax is probably correct. Whether the logic is correct, at this point we don't know. We have not tested what we've done. We can run this, but it won't do anything. We have a main. The main is empty. The method isn't even being called. At this point in the top coder competition process, you would submit this code to Top Coder, to their website, and they would test it for you. They would submit your code against these examples plus a bunch of other examples to see if it gave the correct results. You wouldn't have to write a main. In our world, though, we've got to write our own main, which is a good exercise. And if you look back at the pseudocode, it is, in fact, enhancement 0. We need a main. That's the next thing that we'll do. We need an object to work with. The object is called Blackjack winner. There's our declaration and instantiation of that object. Now I can call the method. The next thing I'll do is create a variable that I can use to store my results. Amount. And then I'll call the method amount equals b dot. When I press the dot, it brings up all of the properties and methods, all the public properties and methods that belong to the Blackjack winner class and that belong to any of the base classes that Blackjack winner inherits from. As we know, all Java classes by default inherit from the object class. Therefore, anything you see in this list that we didn't do is in the object class, which was the base class for Blackjack winner. The only thing we did was winnings. So we need to provide some test data, 1, 2, 3, 4, 5 different integer values. Fortunately, those have been provided for us. Example 0, 10, 20, 0, 21, and 0. 10, 20, 0, 21, 0. Let's print out what we got. Hopefully, when we pass in 10, 20, 0, 21, 0, we'll get 10, because that's what the top coder example says we should get. We don't even have to think about it. Someone designed this test case for us. If we designed our code correctly, we'll get the right answer. Again, we don't need to know any Blackjack. Now we have something we can execute. I'll click on the green button. I got 10. I have a slight glimmer of confidence that we did it right. First one we got the right answer. Let's implement the other three. Example number 1, 26, 21, 1, 21, and 0. I'm going to copy and paste in my main because it's the same code over and over. Just edit the relevant parts. 26, 21, 1, 21, 0. 26, 21, 1, 21, 0. And I'll label that as example 1. After the copy and paste, the only changes I need to make are the 5 test data values and the example number. If I run it now, I get -26 for example 1. And according to this top coder example, it is -26. That's a good thing. I'm 2 for 2. Okay, let's do the other 2. The next one is 100, 25, 0, 21, and 1. 100, 25, 0, 21, and 1. The last one is 78, 22, 0, 23, 0. 78, 22, 0, 23, and 0. Change that to example 3. And there is a very rudimentary test name. Are those good test cases? I have no idea. They do not appear to be a complete exercise of what we wrote, but it's a start and it's what we were given, so it's better than nothing. When we run this, for example 2 I got 150, for example 3 I got -78. If I look back at the the top coder document, those are the correct numbers. At this point then I've done the implementation of the pseudocode and I've executed enhancement number 1 on the list at the top of the pseudocode.